Very good. All right. Today, the 13th of December 2024, we continue with the course EDUC 802, which is a educational statistics 2. And then we have a set of questions. And I think this is the longest so far. We have 65 questions. So in the meantime, we can start with multiples of 5. Multiples. Okay. Multiples of 5. In this case, we'll be able to solve 13 questions. And if we have enough time, remaining time, we can spend it on solving more problems. So to start with question number 5. Question 5 says, which of the following is not an assumption of the one sample t-test? Which of the following is not an assumption of the one sample t-test? So which of them is not an assumption of the one sample t-test? Okay. So I need to attend to something. Just give me 2 to 3 minutes. Okay. Okay, I'm back. Sorry for the little interruption. So we can go back to our screen. All right. So question number 5 says, which of the following is not an assumption of the one sample t-test? A, observations must be independent. B, the data must follow a uniform distribution. C, measurements should be on an interval or ratio scale. D, sample mean distribution should be approximately normal. This is a very tricky question. Okay, and it is talking about the assumptions of parametrics, right? Assumptions of a parametric test. So which of these is the correct answer?
Answer is D, sir.
The answer is D. That is not an assumption of one sample t-test. I would like to say no, yes, but it's very confusing. The sample mean distribution should be approximately normal. It's actually an assumption of parametric. But I know where the confusion is coming from. The data must follow a uniform distribution. That is the assumption that is not there. Look, uniform distribution here, right? Not normal distribution. So the answer is B. The sample mean distribution should be approximately normal. That is correct. And that is what will give us this. The central limit theorem will give us this. Okay, take note. Problem number 10, that's the next problem. Problem 10, what is the power of a test if type 2 error, beta, I should have asked you this, is 0.2? What is the power? Remember power? Power equals to 1 minus type 2 error. All right? And this will give you 1 minus 0.2, which is what? 0.8. And 0.8 is actually equals to what? 80%. Okay? So the power of a test which type 2 error is 0.2 is actually 80%. So the right option there is option C. Are we okay? Question 15. You can always stop me if something is not clear. So if, as I continue talking and you didn't stop me, I will assume that everything is fine. Okay? Problem 15 says, what does Cohen-D measure in hypothesis testing? What does Cohen-D? Okay? Cohen-D's measure in an hypothesis testing. A, statistical significance. B, practical significance. C, sampling error. D, non-hypothesis validity. You shouldn't think twice before you know the answer is about what? Effect size, which is about the practical significance of your findings, right? The right option is option B. Is it correct? Okay, so we can go to problem 20 very quickly. It says, a study with the sample mean of 42, the population mean of 40, has a standard deviation, sample standard deviation to be 5.17, and the sample size is 15. Gives t-test, t-statistic to be 1.5. What is the conclusion at alpha equals to 0.5? Okay, you have the t-statistic to be 1.5. You have the degree of freedom. Remember this, to be what? 15. They now ask you, what is the conclusion? Are you to reject the null hypothesis or to accept the null hypothesis? This one is a significant level. 0.5 is a significant level. So before you know whether to reject or to fail to reject the null hypothesis, you need to find the p-value. Remember this. You need to find what? The p-value. Finding the p-value requires you to look for your table. And looking at the table, sorry, somebody should have asked me this. You see what I'm saying? The degree of freedom, is it 15 or 14? Tell me, the degree of freedom is what? Right? Because the sample size is 15.
It's 14, sir.
Exactly. So the degree of freedom should be 14, n minus 1. So before you know the conclusion to make, you need to calculate the p-value. And for you to calculate the p-value, you only need the degree of freedom and the t-statistic, which you have been given to be 1.5. So you need your table. you need your t-distribution table. I think I have it here. I think here. Yeah. This is our t-distribution table. Okay. Remember our t statistic is 1.5. Degree of freedom is 14. So you look at this. So unfortunately, I cannot write on this. I should be able to write on this, but unfortunately, I cannot. Okay. So just look at the role of 14. I will read it out for you so that you'll be able to follow it. You have 0.00, where you have 14 here. What does that? No, I'm not calling anything. So you have 0.00 here, then 0.692, 0.868, 1.076, 1.345, 1.761. This is where you are going to stop, because 1.5 is between these two numbers. So when you look up, you have 0.2 and then you have 0.1. So your p-value is between these two numbers. It is less than 0.2 but greater than 0.1. It is what? Less than 0.2 but greater than 0.1. If a p-value is greater than 0.1, okay? If a p-value is greater than 0.1, what are you going to do? Are you going to reject or fail to reject the null hypothesis? If your p-value is greater than 0.1, are you going to reject or fail to reject?
To reject.
If your p-value is greater than 0.1, if p-value is greater than 0.1, what is the conclusion? What is the conclusion? I'm waiting for your response. If p-value is greater than 0.1, what is the conclusion? If the p-value is greater than 0.1, what is the conclusion? You need to unmute yourself before you speak.
You reject it, sir.
You reject when the p-value is greater than 0.1?
We fail to reject. We fail to reject.
This simple trick. You shouldn't
take it's when it's less than 0.5, then we reject it.
Now it is greater than 0.1, which is far greater than 0.5.
You fail to reject, sir.
So you fail to reject.
No, you fail to reject. That's the answer.
If p is less than or equal to 0.05, you reject. Whenever p is greater than this number, you do what? You fail to reject.
Fail to reject. Thank you.
You fail to
reject.
Now, in our case, now the p that we have is 0.1, for instance, because it's greater than it. So 0.1 is far greater than 0.05. So therefore, you fail to do what? To reject. You fail to reject. So the right option there is option B. Take note. Okay. We go to the next problem, and that is problem number 25. Question 25. It says, what is the t statistic for a sample mean of 78, population mean of 80, standard deviation of 12, of what? 12.11, then sample size of 45. So what is t statistic? By the formula, t statistic is what? X bar minus mu the sample mean minus the population mean divided by standard error, which is standard deviation divided by n, the square root of n. This is the formula for one sample t-test. And you are given all these things, just plug it in. Your t will be the mean, 78. Okay, minus 80 divided by standard deviation 12.11 divided by the square root of 45. 78 minus 80, that is minus 2 divided by 12.11 divided by, what is the square root of 45? Calculator people. What is the square root of
45?
Is what? 6.71, maybe 6.71. So minus 2 divided by what is 12.11 divided by 6.71. Okay, please confirm these answers. I've not done them before, so I don't know whether it is right or wrong. We are just doing it now. Okay, from here I got 1.05, 1.805. So we need to say minus 2 divided by this number. 2 minus 2 divided by 1.805. So it's around minus 1. Let's say 11 or 10. So t statistic is minus 1.11. The option is there. That is option A. The t statistic computes the what? The t statistic for the set of data, x bar, that is the mean, is given to be 42. Of course, this is the mean of the sample. And the mu, which is the population mean, is given to be 40. Standard deviation is given to be 5.17. And then we have the sample size to be 15. Because we have just only one mean. All right. So this is by the formula. It is given as what? Can you remind me of the formula for the one sample t-test? X bar over standard deviation, x bar minus mu over standard deviation divided by the square root of what? The square root of n. Is it okay, everybody? I have to believe this formula is correct, and I think that's what we did last week. Yep. And I said the quantity, of course, standard error is what? The quantity s over the square root of n. That is your standard error. So, yep, you can mute yourself. If you want to say something, just stop me. All right. So standard error, we can start our computation from there. So standard error is equals to standard deviation 5.17 divided by the square root of 15. Okay, so this is 5.17 divided by, so what is the square root of 15? What is the square root of 15? Who is helping us out with that? Square root of 15. $3.873. 3.873. Is that what we got the last time? Okay, we've not reached there before the network became horrible. So this is 3.873. All right. So what is now the standard error of the mean? 5.17 divided by 3.873. Punch your calculator and let us know what the answer is. What do you get? What do you get? $5.17 divided by 3.873.
1.334.
Thank you, ma. 1.335, right?
1.334. 1.334.
Yes, when you approximate 1.335.
1.335. Thank you. When you approximate.
Okay.
Okay. So we have got our standard error. So we can easily now compute our t statistic, which is x bar minus mu over s over the square root of n. So x bar, the mean of the sample mean is 42 minus mu 40 divided by standard error 1.335. Okay, this is 2 divided by 1.335. All right. So what is 2 divided by 1.335? Any luck?
1.50.
You got 1.50? Any contrary opinion? So the t statistic is 1.50, and option is there, which is option B. Okay. So thank you very much. As easy as that, and that is how it comes out easy, provided you know how to manipulate your way. And you have to be very careful in punching your calculators so that you don't make mistakes that can cost the right answer. So I think, yeah, we now have some questions here that, these questions were missing in the first version of the tutorial question. Now, if you check your Google Drive, you will find the second version, the updated version that contains the missing questions. So we move on to the next question, and that is problem number 35, according to our agreement. So problem 35 is a simple question, or a conceptual one. How is the variance of a probability distribution defined conceptually? How is the variance of a probability distribution defined conceptually? A, it measures the total number of outcomes in a distribution. It quantifies, that's B now, it quantifies the average deviation of outcomes from the mean. C, it indicates the probability of the most frequent event. D, it defines the spread between the maximum and minimum values. How is the variance of a probability distribution defined? Yeah, who is going to attempt to this question? What is the right option?
B, sir.
Option B. So somebody says option B. So we have the first option, option B. Any contrary opinion? Do you agree with option B?
No, sir, it's D, sir.
Okay, another person says option D. Okay, yes, 50-50. Any other contrary opinion?
So the answer is C.
C, option C. Wow, this is a tough question, but the question now is dividing the class. Any contrary opinion? Anybody going for option D? Before we evaluate all the answers. Yes, we have three options, right? Okay.
Yes, sir.
Let me start from the let's say from the lowest, from the bottom. Let's see option D. Somebody suggested option D. It says the variance of a probability distribution defines the spread between the maximum and the minimum values.
No values.
So, what quantifies the spread between the maximum and the minimum value is what is the range, right? Range, that is a range. Yes? Range is the one that talks about the max minus the what? The mean, right?
Minimum.
The max minus what? The mean. That is the range. So this option is knocked out. Let's go to C. It indicates the probability of the most frequent event.
That's the mode.
That's the mode, right? Excellent. So which, again, not talking about the variance, but the most frequent event, the most occurring event, its probability, something close to the mode. Thank you. So again, we knock this out, right? Okay. Okay. So since we all agree it cannot be A, then it must be B, yes? And the answer must be there. So the right answer is actually B. It quantifies the average deviation of outcomes from the what? From the mean. And that is even the definition of the variance, right? Variance is about the spread, yes? Which is x minus x bar, right? Squared. Deviation from the mean, n minus 1. This x minus x bar is deviation from the what? From the mean. So they just bring in some kind of probability terms like outcomes, and then it must be the variance. So the right option there is option B. Thank you. Nice one. So you see, even though the questions are not calculations, they can be so tricky like that. All right.
Exactly.
Let's go to question 40. Calculate the t-value for this sample. Statistics. So we have x bar to be 6.5, mu to be 5, standard deviation to be 1.5, and the sample size to be what? To be 25. Again, we use the formula. T statistics, x bar minus mu divided by s over the square root of n. And that is the standard error, right? Is s over the square root of n. So we find this first. What is our s? Standard deviation is given to be 1.5 divided by the square root of n is what? Is 25. Are we okay? Then this is 1.5 divided by the square root of 25 is what? Is 5. If you do this very well, we should get it to be 0.3, right? Is it okay? 0.3. When you divide 1.5 by 5, you get 0.3. All right? So that is the denominator. So our t statistic is x bar minus mu divided by 0.3. And what is our x bar? 6.5. Mu is 5. Okay? So we have 6.5 minus 5 divided by 0.3. So this is a 1.5 divided by 0.3. Okay? And this is a 15 divided by 3, which is equals to 5. Do you get 15 divided by 3 is just multiply numerator by 10, multiply denominator by 10. You know, 10 over 10 is 1. So multiplying both of by 10 over 10 is multiplying by 1. So you are not doing anything substantial. You are just trying to make work easier for yourself. Okay? And when you multiply 1.5 by 10, you just shift the point forward and it will become 15. And when you multiply 0.3 by 10, you just shift the point forward and it will become 0.3. And 0.3 is 3. So 15 divided by 3 is 5. So your t statistic is actually 5. All right? So an option is there, option D. Are we okay? Is it okay, everybody? So you can see the more you practice these questions, the better you become proficient. So we are using the same formula over and over, and we are just using different numbers. By the time you do it yourself, you will become master of it. So this is the essence of solving some of these problems together, even though the idea is the same, but the numbers are different. But the more we repeat it, the more it gets into us. So let's go to the next problem. This is problem number 40, right? So let's go to the next problem. That is problem number 45. Okay. And problem 45 says, for a test statistic, t-value and degree of freedom 44, what is the p-value? Amazing. T-value is given to be minus 1.12, and then degree of freedom is given to be 44. Then they are not asking for p-value. So this question just wants to test your ability to reach the table. Your ability to read what? To read the table. Exactly. So you need to bring the table in front of you now and then read through it. Yeah. Remember, we have our t statistic to be minus 1.12, right? Degree of freedom to be 44. Okay?
Yeah.
So the degree of freedom to be 44, we come down here. Unfortunately, I cannot write on this, so you have to bear with us.
Let's use the two.
So just, I will be reading about this image. Oh, I cannot write on it. Okay. Look, you need to look for degree of freedom 44 by the side here where we used to look at it. You see 30 is there, 40 is there, but 44 is not there.
But there's no 44,
So we have 60. So you look for the closest number to 44, which for me it is what? 40.
40.
All right? Again, when you look at all the t values, you can see none of them is negative. All the numbers in between here, they are all positive. So just ignore the negative sign. Consider everything to be positive and then do your work. You are looking for the t value of 1.12. Looking straight on 40. Oh, I can do this one. Very good. Looking straight on 40, yes, this place.
But I use the Kuso, sir, yes.
Yes, yeah. Looking through that place that I've highlighted. So we need to start reading 0.000, 0.681, 0.851, 1.05, 1.30. Can you see it now? What you are looking for is between these two numbers. It is between 1.05 and 1.30. So we are going to look up. That will be between these two values. Okay? That will be between these two values. Sorry, this is not so picking, but we can get it right. It is between 0.30 and 0.20. The p-value we are looking for is between these two numbers, okay? All right, between these two numbers. Oh, this one is good. It's between these two numbers. Okay? Excellent. So, look, we don't know the exact number. The way you do it is just that. Just go back to the options. Which of the p-value falls between these two numbers? And that is the answer. Try to note it to 0.30 and 0.20. Now, let's go back to our notes. Okay. So we have got our p-value to be between 0.30 and 0.20. So now look at the options. Look at the options. Which of these option is between these two values?
0.20.
0.20 or 0.27? Wow, this one is tough.
Okay.
Which one is between?
It should be 0.27.
0.27.
Oops. 0.what?
0.27.
Excellent. Excellent. 0.27. It cannot be this number. The p-value is between here. Okay? So the p-value
Yeah.
that is here is 0.27. Thank you very much. So that is how you, and this is the only number that is between these two p-values. Do you understand now?
Yes, sir.
Excellent. Let's go to the next problem. That is question number 15. Problem 50 says, which of the following best explains the falsification principle in NHST? Falsification principle in NHST. A, proving the null hypothesis to be true. B, attempting to disprove the null hypothesis using data. C, confirming the alternative hypothesis without bias. D, proving the theory absolutely. Let's roll in your options. Tell me.
To the following best explain the falsification principle. So what is NHST?
Do you remember the falsification? Yes. Option A, is that correct? I even forgot to remove my answer from question 49.
Bonus.
Yeah, I'm going to edit it.
Ah.
Yeah. Remember, falsification principle, what you are doing there is just to disprove what? The null hypothesis using what data. That's why you reject the null hypothesis. You disprove it. You first and foremost assume it is true, and later you reject based on the data. Okay? So the answer is what? The answer is actually is B. Attempting to disprove the null hypothesis using what? Using data. Okay, the next problem, that is problem 55. What does the significance level alpha represent? What does significance level alpha represent? A, the probability of correctly rejecting the null hypothesis. B, the threshold of accepting the null hypothesis. C, the probability of rejecting the null hypothesis when it is true. D, the effect size required for significance. Remember alpha level?
I think it's B.
Do you remember alpha level? Alpha value? Or we call it what?
Yes.
Type 1 error. Okay? The amount of error you can accept as a researcher. Yeah? What is the right option?
The option is C, sir.
Threshold probability.
Yes, answer is C.
The
I
answer
think
is
it's
C.
Is C,
Somebody
yes.
Yeah.
say B. We have only one correct answer.
supposed to be rejecting, not accepting, but I think it's
Mhm.
C or it's also rejecting
Yes.
the hypothesis.
The probability
Rejecting
of
the null
rejecting the
is
null
C.
hypothesis when it is what? When it is true.
Yes.
And that is the definition of type 1 error. You commit
Yes.
type 1 error when you
I think
reject. Yes.
Zauna.
So when you reject a true null hypothesis, that is when you commit what? Type 1 error.
Yeah.
So the right option is option C. Okay. Excellent. We go to problem 60. Question 60. It says, why does failing to reject the null hypothesis not confirm it is true? Why? The question of why is a very delicate question. Why does failing to reject the null hypothesis not confirm it is true. A, sample size may be insufficient to dictate meaningful effect. B, it always suggests the test was conducted incorrectly. C, type 1 error probabilities are too high. D, p-values cannot be calculated for the null hypothesis. Take your time to read the question again, gently and slowly. I give you 1 minute.
Type 1 and 2, I think.
Sir B.
B. We have option B.
C.
Option C.
When does failing to reject the null hypothesis not confirm it is true?
Okay, let's see between B and C which one is correct. Again, let's start from below. Any contrary one? Okay. C says type 1 error probabilities are too high. There's no correlation between the question and this one. Type 1 error probabilities are too high. No correlation. We are talking of when you fail to reject the null hypothesis. That is when your P is what? Is greater than 0.05. Okay? When your P value is greater than 0.05. This is when you fail to reject the null hypothesis. Does that mean the null hypothesis is true? Does that mean there is no significant difference between the performance of male and female? Does that mean that? So why does failing to reject the null hypothesis not confirm it is true? That's the question of why. So this one may not be the correct one. Let's see B. It always suggests that the test was conducted incorrectly. No. This is also not feasible. You can conduct your test correct. How many tests we have conducted? Even in our class, we do some calculations and then we got it correctly, and then we find out we have to fail to reject the null hypothesis. Okay? So that means, yeah, so this is also not. So now we are having people coming up for A now. Okay, A says sample size may be insufficient. Exactly. So detect meaningful effects.
Yes.
So it can be too small. Yeah, exactly. If it is too small, the central limit theorem will break down, and then you may not be able, especially when you're using t-test, it has very weak power to detect effects. And, so the right option is what? Option. Okay. Then we now go to the next problem. That is problem 65. It is also a conceptual problem, and it says, which of the following best explains type 2 error, the beta error? A, failing to reject a true null hypothesis, rejecting a false null hypothesis, failing to reject a false null hypothesis, rejecting a true null hypothesis. Wow, this is confusing, yes? So which option is correct? Type 2 error.
Correctly reject the null hypothesis. Rejecting a true null hypothesis.
Type 2 or not type 1? Someone say rejecting a true null hypothesis. That is D, option D.
A false null hypothesis. B.
B, okay. Okay. Then anybody going for A and B, C?
Probability that the test correctly rejects the null.
Peter.
Hmm? C, okay. We also have C. Wow.
A, B, C.
Anybody going for D? Anybody going for D?
When the alternative hypothesis.
Okay, somebody's reading from the note. Okay, tell us what you read from the note. Let us write it down, then we correlate with what is here. Tell us what you
Yes,
have.
what I'm saying. Yeah, they said the power of statistical test is the probability that the test correctly rejects the null hypothesis when
No,
the
we are
alternative hypothesis is true.
no type 2 error, not power.
Oh, sorry. It's true. I'm reading the wrong part. Can't locate it too. I can't locate it. Let's check it's inside this.
Yeah. Yes.
So I can't locate where type 2 error is here.
Okay. So the right option is what I've put in the square bracket. So when you fail to reject a false null hypothesis, you have committed what? A type 2 error. When you fail to reject what? A false, a false null hypothesis is to be what? Is to be rejected. When you now fail to reject it, you have committed what? A type 2 error.
Type 2 error.
That's when you accept the false null hypothesis. And when you reject a true null hypothesis, now when you reject a true null hypothesis, that is when you commit type 1 error. We did it before, right? Look at it here. Failing to reject a true null hypothesis, right? Rejecting a true null hypothesis. Yeah. So we have come to the end of the multiples of 5, and we still have some time left. I think we should go over it again and pick another multiple of number, right? So this time maybe let us pick even, right? Maybe multiples of 4, something like that. So when we get to the one we have taken before, we just skip it. So let's see question 3. Question 3 says, what does a p-value, question 4. What does COND measure in hypothesis testing? I think we did something like this before. It's just a repetition of what you have done before. I'm talking about question 4. What does COND measure in hypothesis testing? A, statistical significance. B, practical significance of the findings. C, sample size effect on p-values. D, type 1 error rates. So this is just what? B. We talk about what? The effect size, practical significance of the findings. So we go to problem 8. Problem 8 says, a study comparing sample and population means yield t-value to be minus 2.23, degree of freedom to be 19, and then p-value to be 0.004. What is the interpretation? What is the interpretation? For you to know the interpretation, you need to make a decision. This is p-value that is given to be 0.04, which is less than 0.05. Is that correct?
5.
And
Yes.
when p-value is less than 0.05, you need to do what? Reject
Reject.
the what? The null
Hypothesis.
Hypothesis. Okay, so this is your decision. And now you cannot interpret. Let's not go to the option. The null hypothesis is supported, no? The sample mean significantly differs from the population mean, correct? Because when you reject the null hypothesis, you say the mean difference is what? Significant. Okay? So the right option there is what? Is option B. I don't have to read others. So let's go to the next problem. That is problem number 12, right?
12.
Problem number 12. It says, what does a type 2 error represent? Oh, come back to our question again. So what does a type 2 error represent in hypothesis testing? Fail to reject a false null hypothesis. Fail to reject a false null hypothesis. Okay, excellent. So we go to the next problem. That is problem 16. Problem 16 says, in hypothesis testing, which assumption is not required for a one sample t-test? A, normality of the sample mean distribution. B, random sampling. C, homogeneity of variance. D, interval or ratio level of measurement. This is an interesting one. What is the option?
D.
B. Amazing.
D for dog.
D for dog. Okay.
Yeah, sometimes all these answers must be entering somebody's eyes.
So, anybody or everybody, you agree with D?
No idea.
Remember, t-test is a parametric test. So you need your data to be continuous by default. It must be measured on either interval or ratio. That is correct. The incorrect answer here is what looks correct, which is what? Which is what? Is B, random sampling. You don't need random sampling. Or do you? It's not part of the assumption, right? So you just need your mean to be normally distributed. Okay? So homogeneity of variance, that one is needed as an assumption of a parametric test. Okay? So, but that C also can also be contested. Like it is only when you have two sample t-tests that you can talk about homogeneity of variance.
All of us, every Friday, 5 to 6.
All right, so that also can be contested. That's when you have two sample t-tests, that is when you need homogeneity of variance. So maybe I'm tilting towards saying that the right option should be option C instead of B. So let us argue this out. Look, option C is more correct because it says homogeneity of what? Variances. Move this man on. Okay, what is more correct is the homogeneity of variances, because here we're talking about one sample t-test, right? One sample t-test, we have just only one group. We cannot have variances. We only have a variance, right? So what is more correct is actually option C and not option B is wrong. Option D is wrong, and the right option is option D. Though homogeneity of variance is an assumption of parametric test, but for one sample t-test, it is not. You need homogeneity of variance when you have more than one group, like you have two groups. Okay, So the right option here is what? Option C. There are other sampling, we can manage it because we are dealing with random variables in the first instance. All right. So we can now go to the next problem. That is problem. Now problem 20, we are going to skip it because we have done problem 20 before. So we go to problem 24. All right. When we are doing multiples of 5, we must have done problem 20. So problem 24 says, compute T statistic. Compute what? T statistic. You are given X bar, the sample mean to be 70, the population mean to be 68, the standard deviation to be 5, the N to be what? 36. So we go by our formula. T statistic is a mu or X bar or mu minus X bar or X bar minus mu divided by standard error of the mean.
Mene
Okay?
kika ɗauka
That's
zaki ba?
X bar minus mu divided by
Ine-
S over
To
the
ina
square root of N. All right?
ba ni
So
haka ne.
S over the square root of N, this is equals
Ki dai ban
to,
haka.
our S is 5, then the square root of N is what? 36. So this gives 5 over, the square root of 36 is what? Is 6. Is it okay? So 5 over 6.
Yes.
I can leave it like this. Then to get my T value, it will now be mu X bar minus mu. Our X bar is 70, our mu is 68. 70 minus 68 divided by 5 over 6. 70 minus 68, that is a 2 divided by 5 over 6. 2 multiplied by 6 over 5. Is that correct?
Yes.
Remember we did this one at the beginning. So this is 12 over 5, which is 2.4. So T statistics is what? 2.4. The right option there is option C. Are we okay, everybody?
Yes, sir.
Excellent. So we can go to the next problem. That will be question 28. 28 says again, calculate. Oh, it's like we have not done this at all. Calculate the effect size. D, given the mean, the sample mean to be 6, the population mean to be 5, and then the sample standard deviation to be 2.02. We have not done this at all. Effect size, coen D, is given by the difference in the mean divided by standard what? Standard deviation. All right? Yes. So this will be the difference in the mean, 6 minus 5, divided by standard deviation 2.02. And this is 1 over 2.02. So what is 1 over 2.02? 1 divided by 2.02. Calculator people.
0.49.
2.0. Excellent. You got 0.50, right?
50. Yes.
0.495. When you approximate, get 0.50. So the right option is there or not? Problem 28
It's
is there. That's option B.
yes, sir.
Okay. Excellent. So we can go to the next problem. That is problem 32. Problem 32 says, a
Excuse me,
sample
sir.
yields X bar.
Excuse me,
Yes,
sir.
please, go ahead.
That
Please, I'm
number
listening to
28.
you. Go ahead.
The number 28, please. We
Yes.
still have option A, please. 0.49.
We still have option, where is it? 28. Yep. 0.49.
Yes, sir.
Yep. But what we got is that is what a distract option. That's what it does. The full option is 0.45. Sorry, 49. 1 minute. If you press the calculator, you get 0.495. Okay?
495.
50,
Yes.
then it continues 4950. This is a recurrent decimal. Okay, if you want to stop at 2 decimal place, you must round this up, right?
Yes.
Okay, sir.
You can't say 0.49. If you want to stop at 2 decimal
It's okay.
places, you need to look at what is in front It's up to 5, you add 1 to this. Aha. So that is a very good option to confuse somebody. I like that. We leave it there. Yes?
Thank you.
Excellent. So the next problem is problem 32. It says a sample yields X bar to be 78, standard, the mean of the population to be 75, standard deviation to be 10.17, and the sample size to be 30. What is the p-value when you are given the t-value to be 1.84? Remember, you have the sample size n to be what? 30.
30.
You can use this to get your degree of freedom to be what? 29. So this just want to test your ability to read the table. You have your t-value, you have your degree of freedom. So we go to the table. Let's go to the table. Please note our t-value is 1.84. Our degree of freedom is what? 29. So let's go to that table. You got it here. Now, I believe you can all see this table, right?
Yes, sir.
So our degree of freedom is 29. We go to 29. So this is 29.
Yes.
Excellent. So we are going to read across like that. Our t-value is 1.84, right?
Yes.
Is that correct? So we can start reading. We have 0.00, 0.683, 0.854, 1.055, 1.311, 1.6. So that means we have to stop between these two, 1.311. No, it is not, but it's between this and this. Our t-value is 1.84, right?
1.84.
So we must be between
1.684 and 2.02.
Exactly. So this is where we must be. All right. So we then look up. Our p must be between this number and this number. Between 0.10 and 0.05. This is where the p number must be, right? We don't know the exact p number, okay? But we know where it must fall. So we are not going to take these two numbers now. We go to our option and we look at the option that falls between these two numbers. So we go there. All right? We know our range now. Exactly. So p-value is between 0.10, all right? And then what?
0.05.
This is where our p-value is, our answer. So we now look at the options. Which of these p-value fall into this category? All right. This is also nice. So which option is correct?
C.
Excellent. Option C.
It's C, sir.
And you can see, yes, option B is very tempting, okay? But it's not the answer. Option B is tempting, but it's not the answer. Option C is the one that fits into what we are looking for. This is how you manipulate your way in the exam when you don't have the software to use, but you have your table, and then you can use your knowledge to pick the right answer. So we go to the next problem. That is problem 36. We still have 5 minutes. We can do this. Problem 36. Problem 36 says, what is the defining property of a uniform probability distribution? A uniform probability distribution. A, the probabilities increases linearly across the sample space. Uniform, B, all possible outcomes have equal probability. C, the distribution is always symmetric. D, it is only applicable to continuous random variables. What is the answer? What is the answer?
The answer
Is
The answer is A. Somebody say D. Any contrary opinion?
I'm in between.
So who is in between? Eh?
Answer, sir.
What do you say?
A is the answer, sir.
A is the answer. Okay, let's see it. Option A says the probabilities increases linearly across the sample space. I cannot remember we ever said this in class, right? Uniform probability, like you have the rectangular probability. That's a uniform
It should be
distribution.
B, big
Rect-
answer.
rectangular. Okay, somebody say D.
No,
It is
B.
only
B.
B. All
No, I'm
possible
going.
outcomes have equal probability.
Mm.
That is correct. All possible outcomes have what? Equal probability. Exactly. That's a uniform distribution.
Yeah.
Okay, it's uniform. Thank you. I think this is a good place to stop. The next
Okay,
problem,
mommy.
problem 40. So okay, let's see. We can skip question 40 because we have done it before.
You've done it,
Then
yes.
maybe question 44 is about computing this statistic. Just use the formula and then you'll be fine. Okay. Then we can go to question 48. Again, it's on computation of T statistic. Just use the formula and you'll be happy. All right. So question 48, the same. So T is what? X bar or mu minus X bar. 1 minute. Is X bar minus mu over S over the square root of what? N. X bar is given to be 88 minus mu 85 divided by 8 over the square root of what? Of 16. Okay. 88 minus 85, 3 divided by 8 over the square root of 16 is 4. 3
Yes.
over 8. Over 4 is 2. So the answer is 1.5.
1.5.
Okay. So the answer is the correct option A. So the next problem is problem 52. What is a common misconception about failing to reject the null hypothesis? It means the null hypothesis is true.
What is a common misconception about failing to reject the null hypothesis?
It means the test was conducted incorrectly. So the conception, when you fail to reject the null hypothesis, it means the null hypothesis is true. That is the conception. 52 now, then 56 will be the next thing. What is one disadvantage of using alpha too low? When alpha is too low, what is the disadvantage? A, it reduces the chance of detecting true effects, that is low power. B, it increases the risk of type 1 error. C, it increases the sample size needed. It diminishes the importance of what? Of p-value. Okay, what is the right option here? That's the problem number 56. So the right option is A. It reduces the chance of detecting true effect because you are going to have low power. The next one is 60. We have done it, so we skip it. Then the last question there is question 64. What does a small effect size with a significant p-value suggest? The null hypothesis is definitely false. The practical significance of the finding is limited. The study design is inherently flawed. The sample size was too small. Okay, what that suggests, without wasting our time, is that the practical significance of the finding is what? Is limited. If your effect size is small, that means it is not it has low effect size, and that means the practical significance is what? Is small. I think this is a convenient place for us to stop today. We continue next